Students, this is the video help portion for the Unit 2 study guide in preparing to take your ALEKS practice quizzes 2.1 to 2.3. I've taken the most problems that are most frequently causing trouble for students, and we're going to go over them. This section is in the back of your study guide, video practice for ALEKS 2.1 to 2.3. Let's read this together. Suppose that points R and S are points on a number line. The distance R to S is 8. S line at 16. Where could be R located? So let's put the information that we have here. R and S are points on a number line. We're told the position of S, so let's plot S. It's at 16. So over here would be somewhere 0, and then you have your negative side of the number line and your positive side of the number line. It says the distance R to S is 8. That means the distance between point R and point S has to be 8 units. So I could start at 16, I bunny hop 8, 1, 2, 3, 4, 5, 6, 7, 8. 8 units, and I asked myself, what is that position? So 16 going to the right, 8 bunny hops. It's going to be 24. That's could be position R. Or I could go this way. 1, 2, 3, 4, 5, 6, 7, 8. And that position would be positive 8 for R. So technically, R could have 2 positions. That's why you're told to separate them with a comma. The position of R could be at 8, or it could be at 24. Segment addition and midpoint. Said in the figure below, G is the midpoint of FH. This is really helpful if you color code it. So FH, G is the midpoint. F is between E and H. Between doesn't mean the middle. If F to H is 12, and E to G is 10, it wants you to ultimately find E ultimately H. Now, rather than focus on the pink, which you're trying to find, simply ask yourself, what is possible, or what can you do? What's the simplest thing you can find? Well, we know there's a midpoint here, so we know from G to H is 6, and from there to there is 6. Then you ask yourself, what else can I find? Well, if you put your fingers there to there, that is 10. And from here to here is 6. That means, from there to there, 6 from 10, that's 4. Let's see if we have enough information. We went E all the way to H. Well, we have 4, and then we have 12. Of course, our length there would be 16. So E to H, the distance is 16 units. Segment addition and midpoint. You're told that here are the endpoint of 3 segments. And we want to complete the statement. We're going to be finding the distance of 3. Finding the distance. So at the top of your paper, let's find that distance. these three different colors. I'm going to find the distance of B to C. So get out some scratch paper. I'm going to do BC right here. B to C. Make a template. And then we went F to G. Some space. Make a template. Always make a template first. And then we have J to K. Okay, so let's plunk in our numbers and see what we get. I'm going to go left to right. So I have 0 and 5. Left to right, 2 and 4. That's going to be negative 5 squared. That's 25. That's going to be negative 2 times negative 2. That's going to be positive 4. So I get B to C is square root of 29. Is B to C. F to G. Again, left to right. Negative 6, negative 7, 0 and 5. Double negative makes a positive. That's 1 squared. That's 1 plus 25. So that ends up being square root of 26. That is F to G. So we have here double negative makes a positive. Ends up positive 1 squared. Double negative makes a positive. That's 16. And we end up with J to K being square root of 17. So let's take a look at our next page. BC equals the square root of 29. FG equals the square root of 26. And then we look at the last one. JK equals the square root of 17. Then we ask, are any of them congruent? And if you go through, obviously none of them match. We would check none of the above. If there was any congruency in length, for example, one had the square root of 20, the other had the square root of 26, you would take those lengths and you would say, yes, they are congruent. But in this case, there is no congruence. Therefore, it's none of the above. Last one here. We're asked, what is the equation of this line? The y equals mx plus b. Let's identify what that is. Y equals mx plus b. There's only two things we need here. One, we need a slope. Two, we need a y-intercept. We need a slope, and we need a y-intercept. So to find the slope between any 2 points, there's a couple ways we can take those points. This point here is going to be negative 5, positive 2, and this point here is positive 1, negative 1. We can find the slope by doing y minus y over x minus x. Or you can simply bunny hop it. Oops, double negative makes it positive. That is 1/2. Let's double check that. 1, 3. 1, 2, 3, 4, 5, 6. That's 3 over 6. Yep, negative. So it's negative 1/2. So there is our slope. Bunny hop it or use your slope equation. Now to get the y-intercept, the problem is, if you look carefully, the y-intercept is obviously some sort of eyeball that. So how do we solve for that? Well, we're going to use y equals mx plus b. Y equals the slope times x plus b. B is our variable we want. So we're going to plug in an xy value. Right here, I'm going to plug x is going to be 1. Y is going to be negative 1. My slope is negative 1/2. And then my b is my unknown. So I plug in a value of both x and y, and I could have chosen either point here, either this point or this point. And you're going to solve for b now. So negative 1 equals, that's going to simply be negative 1/2 plus b. I'm going to add 1/2 both sides. Negative 1, we're going to translate that to over 2. That's technically negative 2 over 2. We're going to do plus 1/2. That's going to equal b. This ends up being negative 1/2, which looks about correct. Always visually check it. Equals b. So it's y equals, the equation of this line is negative 1/2 x minus 1/2. And that is the equation of that line. So to recap, we first found the slope, and then we worked on finding the y-intercept.